Hello, a very warm good evening to all of you and welcome to Unacademy. Welcome to another episode in our last lab series, where today we bring for you the important concepts associated with the area of environment and ecology, which is relevant for your prelims examination. Now, why should you watch this video? And what is there important in this session which you might not have covered earlier? So, very clearly in our earlier initiatives of Conquer Prelims, we have covered more than 120 different topics associated with current affairs when it comes to environment ecology. We have covered national parks, wildlife sanctuaries, Ramsar sites, the places in news, the species in news, the conventions in news, etc. and so on. Now, when it comes to the preparation of this subject, majority of the candidates feel that the subject is all about learning which species are critically endangered, which is a protected area, where a particular national park is situated, and that's it. That is the perception of the candidate when it comes to the preparation. But if you check out the reality of the paper in the examination, you will find that out of 15 to 16 questions which appear in the prelims, hardly around 3 to 4 questions are associated with these species nature, then when it comes to national parks, etc. Remaining questions are associated either with current affairs or are associated with some of the important topics in environment which we ignore very easily. So topics such as ecosystems, niche, ecotones, mass extinction, ecosystem engineers, ecological succession, those are the topics which largely remain uncovered for the candidates. In this session, we are not going to cover the places in news. We are not going to cover the species in news, because for that, you can refer to our Conquer Prelims video, where we have dealt with these topics along with the MCQs that can be framed from them. Here, we are going to cover the remaining of the topics which are important for your examination, which will help you ace the examination and stay a step ahead of the preparation. So without further ado, let us initiate the discussion for the topics of the day. But before that, an important announcement. Now, we have been launching various different optional series and various different optional subjects as per the requirement of the candidates. Now, due to and owing to the huge demand, for the first time in English medium, we bring for you Geography Optional on Unacademy platform. The Geography Optional sessions will be starting from 24th of June. You can enroll for that session. Overall, in 350 plus hours, including a lot of attention to the mapping portion and also keeping the text and the syllabus relevant for the examination, we are going to cover the optional paper in as comprehensive a manner as it can be. Every day from 1:30 p.m. to 4 p.m., you will have these sessions from Monday to Saturday. It will begin from 24th of June. You can join this Telegram channel in order to ensure paper evaluation, one-to-one mentorship, and also in order to help you guide through the preparation. You can use the code and avail a discount of more than 50% in your optional courses. Having said that, let us jump into the topics that we are going to discuss today. So today, in total, we are going to discuss these different topics along with the examples, along with the slide details associated. So ecosystem, niche, ecotones, edge effect, etc. These are the topics that we are going to cover. Now, starting with the first topic. And here, the first topic is the first basic portion, that is ecosystem. Now, you might be wondering, what is there to study in ecosystem for the exam? But here, let us understand this in greater granular details. When we talk about ecosystem for any particular region, what do we mean by that? So, ecosystem basically constitutes of the living and non-living factors in a particular area which influences the life and the metabolism of the species living in that region. So, the living community of plants and animals in any area, along with the non-living components of the environment such as soil, air, water, temperature, light, all of that constitutes what we refer to as the ecosystem. So when we talk about any ecosystem, there can be a broader classification into biotic factors, Biotic factors. What are those biotic factors? Let's suppose in any particular area you have the producer community in the form of plants, right? Now for the survivability of a species like tiger, for example, you will need those plant species to survive as well. You cannot have the approach that let's only save the tigers, let's let the plants do what they want, or let the plants have their own particular kind of a destiny, that if the plants are getting desertified, the region is getting desertified, the tigers won't be impacted. They would be, as has been the case in the region of Madhya Pradesh, for example. In the region of Madhya Pradesh, what has come to light is, due to an invasive alien species that is Lantana camara, the native species of plants and grasses, they have been declining in population, due to which the herbivore population of that area, they are reducing in numbers because they are not finding Lantana camara as a palatable food. Now, when the herbivore population is decreasing, you can always imagine the impact on the tiger population. So, these are the biotic factors in the ecosystem. But again, along with that, you have very important abiotic factors. What are the abiotic factors? So, for example, in any particular area, let's suppose the availability of sunshine, the light, the photosynthetically active radiation from the sun which is emitted, that is relevant for the producer community. So, in areas such as the tropics, you will find that greater availability of insolation means there's a greater productivity by the producer community, and that would lead to a better transfer of energy into the herbivores and the carnivores thereafter. So, those are your abiotic factors. These include the conditions of temperature, the conditions of light, the conditions of soil, the conditions of water availability, and the mineral presence, etc. These are non-living factors. Now, it is because of this that you have a greater variation in terms of distribution of organisms from one ecosystem to another. These are the factors which are prone to change. Sometimes what happens is that these particular abiotic factors, they can change suddenly over a period of time, for a temporary duration or for a permanent duration. So, these abiotic factors, let's suppose from one season to another, they are prone to change. If we consider an example of Central Asia, in Central Asia during the summer season, you have the well-established ecological community with the plant species and the herbivore, the carnivore, everything is well established. But when the harsh winters set in, that is when, due to the lack of food, the abiotic factors, they become very intolerable. So, when there is any kind of change in any of these biotic or abiotic factors, the species, they generate certain responses. So, the responses that the species generate, when we talk about the responses, so the responses generated by the species are of various types. One is regulate. What do we mean by this? So, for example, when we talk about any particular, let's suppose we consider ourselves, that is humans. Now, if the situation or if the outside temperature becomes very hot, we start to sweat a lot. We perspire a lot. Now, the evaporation of the sweat is a natural cooling mechanism of the body. So, by our bodily mechanisms, we are able to regulate the internal temperature. Right? When you have, let's suppose, extreme summer condition, the body tends to retain the water. So, you are regulating your body in order to have a better adaptation. This regulate is of two types. One is thermoregulation. Thermoregulation, where the internal temperature of the body is regulated. For example, during the winter months, when it is very cold, our body starts to shiver. That is a body's mechanism to generate heat, to maintain the internal temperature. Then you also have osmoregulation. Osmoregulation is basically the maintenance of the internal fluid systems in the body. Not many species are able to regulate their body mechanisms. We humans are one of them, and some of the mammals also fall into the category. This is one of the response. Other response that the species generate is that of confirm. Now, what is this confirm? Basically, that majority of the plant species, for example, 99% of the species overall, you will find, they come under conformists. Means what? If the outside temperature is very cold, the internal body temperature will also become very cold. The species will die. If outside temperature is very hot, the internal body structure also becomes very hot. So such kind of species, when the external environments turn out to be very harsh, these kind of species, they perish, they die, right? Majority of the plant species, they come under the category of confirm. Then you have another response, the response that is migrate. Now, when we talk about migrate or migration, basically, sometimes the species, they migrate from one region to another owing to harsh conditions, and when the conditions become conducive again in their home environment, they return and they get back. So this is migration. This can be seasonal, this can be annual, this can be semi-permanent as well. And in certain cases, what we are observing is that because of the warming and increased amount of heating, many of the species found in the tropical regions, particularly the marine species, they are moving into the temperate areas. For example, majority of the fishes, large fishes and various different aquatic animals, they are migrating into the areas such as Mediterranean and beyond in order to escape from the very high temperature being experienced in the tropics. That is again a permanent form of migration. By the way, this phenomena of migration and movement of the species away from the tropics into the temperate regions in order to ward off the climate change, this is something which is known as tropicalization. So tropicalization is what? Tropicalization is the movement of the marine species away from the tropics into the temperate areas. Okay, primarily found in marine species or aquatic species. Okay. Now here they migrate from the or they move from the tropics into the temperate regions. From tropics to temperate. Okay. Now here that is a kind of a permanent movement. That is also a response to the changing ecosystem. Now, another response to the changing ecosystem is what we refer to as suspend. Now, suspend is basically where the body metabolism and body actions, they are slowed down. Let's suppose when we consider the polar region. Now, in the polar region, the winters become very harsh. And the availability of food becomes very scarce because you don't have, or the entire region is covered under thick cover of ice and snow. So food availability becomes very scarce. So in those polar areas, many of the species, they choose to go for a long winter sleep where the body's metabolism is slowed down so significantly that your requirement of food itself goes out of the window. So that is suspending your body mechanism. Suspend is of three types. What are the three types? One is hibernation. Hibernation, what is also referred to as the winter sleep. For example, polar bear. Now this is generally observed in the polar areas, in the higher latitudes because the temperature is very, very cold. Then you have what is referred to as estivation. Estivation is what is also referred to as the summer sleep, where due to lack of fluid, lack of water availability and in extreme dry conditions, many of the species, they go for estivation, generally observed in the desert areas across the planet. Then you have, so here you will find small insects, etc. They can go through the phase of estivation. Then you have another form of suspend, what is referred to as diapause. Now, diapause is when you suspend your body metabolism and body activities for an uncertain period of time as long as harsh conditions prevail around you. right? So it is not associated with summer, it is not associated with winter, but as long as any harsh conditions, let's suppose the outside environment is too polluted and you don't get availability of food, so there also the species can go for diapause. Now these kind of activities or this kind of response of diapause is generally found in microbes. Right. So in microscopic organisms, that is a property generally found, for example, in different types of planktons. So here, this is suspension of metabolism for uncertain period of time to be observed in microbes. Okay, in microbes. Now, one particular ecosystem can be shared by multiple organisms together. Now, when multiple organisms or multiple different species live in a particular area, they interact with each other. And we will take a look at what those interactions result in. But before that, we come to the concept of ecotones and edge effect. What do we understand by the term ecotones? First of all, so when we say an ecosystem, you can have various ecosystems, for example, forest ecosystem, desert ecosystem, and so on. So the transition between two different ecosystems, that is the zone of transition, that is known as an ecotone. For example, let us consider this ecosystem as the forest ecosystem. Let us consider this ecosystem as the desert ecosystem. Now you won't come across the case that till here you have dense vegetation and from here you have absolute desertified sands. It doesn't happen like this. Generally what will happen is that those forests will experience a reduction in density of the vegetation. The vegetation won't be that dense anymore. The trees will be lesser and lesser to be replaced by grasses, and then those grasses will lead to desert formation. So that transition is what we refer to as an ecotone. So for example, in between the forest and the desert, you have the grassland, which serves as the ecotone. So in real example, for suppose you consider the region of Africa. Now northern portion of Africa is constituted by the Sahara Desert. Now in the central portion of Africa, you have the rainforest, Congo rainforest. Now from Sahara Desert to the Congo rainforest, there is a zone of transition, what we refer to as the Sahel region of Africa. That is a zone of grassland. That is an ecotone. Now in the case of an ecotone, we know that it is a zone of transition. Now here one particular aspect that you have to keep in mind is this is a zone of transition. Now here you will have those kind of species living in this zone of transition, some of whom can adapt to forest ecosystem as well, some of whom can adapt to the desert ecosystem as well. Now, can these ecotones be man-made or are they always natural? Here lies an important crux. Ecotones can be man-made as well as natural. For example, in many of the cases, when you consider the agricultural fields, farmlands, they also form a part of the ecotone. Okay, so keep that in mind for your multiple choice question. Can be man-made or natural. Okay, so here the example of a man-made ecotone is basically going to be agricultural farmlands. Now in these regions of ecotones, as we have discussed, you can have species which are adaptable to forest, species which are adaptable to slight desertified conditions, and you can also have unique species which are found only in the region of the ecotone. For example, consider the species of elephants. Elephants, you will not find them generally in very dense vegetation, you will not find them in the region of the deserts, you will generally find them in these grasses and the region of the scrubs. So those are the unique species of the ecotones. So in general, what you will find that these regions of ecotones, they are very densely populated. You will have different types of species there. And that abundance of species in the ecotone, increased amount of species diversity in the ecotone, that is known as edge effect. So what is edge effect? Increased species diversity. Increased species diversity in the ecotone. Okay. Now, examples of ecotones. For example, let's say you consider marshland, marshy areas. Now, what are these marshlands? So, when you consider a river or an aquatic ecosystem, now you will have different species in the rivers, and nearby land area is dry, you will have different species living there. In the boundary between the river and the land, you will have marshy areas, moist areas. So, that is where you will find again an ecotone. Then when you consider, let's suppose mangroves, mangroves are also example of ecotones in between the marine ecosystem and the terrestrial ecosystem. Then when you consider, let's suppose, if you consider the example of estuaries, estuaries also you will find in the region of the river, you will find freshwater species. In the region of the sea, you will find the marine or the salt saline water species. In between the estuaries, in the midst of it, you will find a mixture of all these. So, generally in the case of ecotones, you will find abundance of species living there, and that is what is referred to as the edge effect. Okay. Now, after this, we move on to what we refer to as habitat and what is referred to as a niche. This is also an area which confuses many of the candidates. What is a habitat? What is a niche? So, when we talk about a habitat, that represents the abiotic conditions required for the survivability and the survival of any particular species. For suppose, when you consider a species like tiger, now what is its habitat? Its habitat can be semi-arid region, grassland, dense vegetation, mangrove vegetation. That is what is its habitat, right? So, habitat basically is a physical place for the species. It reflects the living place of an organism. That is the habitat. But then, let's suppose in a region where you have a lot of mangroves, no other species living there, and you leave the tigers there. The tigers will die, because they won't get the availability of herbivore population like the deer, right? So, just the availability of living space does not mean that species will be able to survive. You need the biological community to be in place, the biological community and the living functionality of the organism within the food chain for it to survive. That is indicated by a niche. So, niche of an organism is basically the role, the functional role. Remember this, the functional role. Why do we say functional role? Because that organism serves a particular function in the entire trophic level, in the entire food chain mechanism, and that is why it is important. So, the role of an organism within the environment or the ecosystem, it is the functional role or the activity which is played. So, niche oftentimes indicates the combination and a perfect culmination of both biotic and abiotic factors taken together for the survivability of species. In a nutshell, habitat is the living space, niche is the functional role played by the organism within that living space. Okay? Now, as I told you, when in any particular region you have a lot of different species living together, now those species will interact with each other. Now, they will interact in multiple different ways. So, if you take a look at the species interaction, it varies from predation to competition to parasitism to commensalism to mutualism to amensalism. What are these? Predation. For example, in a particular forested area, let's suppose you have the tiger and you also have the deer population. Now, tiger is the predator, deer is the prey. Now, maintenance of the tiger population is very important. Otherwise, what will happen? The deer population will explode. And these deers will start consuming as much amount of grasses and the plants as they can. There is no check available for the deer population, and their population can explode. putting in danger the availability of the producer community. Overgrazing can happen, which can lead to desertification. So that is why predator community is also very important to keep the population of the prey in check, in control. Then you also have what is competition. This is when you have two of the species sharing the same particular niche, sharing the same particular habitat as well, and they compete for the same food source. For example, in many of the protected areas, in many of the forest areas, you have tigers and leopards. Now, the leopard census has been conducted recently. Now, it has been found out that in regions such as Uttar Pradesh, particularly around Rajaji Tiger Reserve, in that particular area, you had the case where the leopard population has declined in that region. And the reason being that they share the same space with the tigers, they share the same food source as is the case with the tigers. While the tigers are able to get the food, the leopards are not. So they have moved on into the nearby urban spaces. Right? So that is competition. Competition is generally when you have the same source of food. Then you have parasitism. Parasitism is a relation between the parasite and the host. Parasite and host. So when we say parasite, for example, we all went through the phase of the COVID pandemic. Now the COVID-19 virus, it was a parasite. Ideally on its own, it could not survive for very long. But when it would enter the host of any particular organism, it would multiply. So parasitism is a relationship where one organism benefits from the other and the other organism is harmed. Right? So one organism, for organism 1, it is positive. But when it comes to organism 2, it is harmful. Right? Virus, humans, etc. That can be the ideal example. Then, what is commensalism? Commensalism means it is that kind of a species interaction where one species benefits out of it, the other species has got no impact. Let us take a look at the examples. So, commensalism is the interaction in which one species benefits and the other is neither harmed or benefited. For example, when you consider the species of dung beetle. Now, dung beetle is a kind of an insect which follows the cattle, the bovine organisms, and they basically start living in the cow dung or the buffalo dung, etc. Now, for a buffalo or a cow, this dung beetle makes no impact at all. For the buffalo or the cow, the beetle is basically foraging on its dung, on its excreta. But for the beetle, it is very beneficial. Similarly, this is the case observed in various different types of species. For example, you consider the cattle and the cattle egrets. Egrets or the cattle egrets are basically these bird species. You will find that many of the times when the cattle move across the field, you will have a lot of these egrets following them. Why? Because owing to the weight, these cattle species, many of the times, they put so much weight on the ground that the insects from the underground, they are forced up. And that is what is utilized and taken advantage of by the egrets. So for the cattle, it makes no difference. But for the egrets, it is the source of food. Right? Then you also have the case of sharks and the remora fish, which is also referred to as the sucker fish. These particular fish species, they nibble on the parasites and the various different infections and the various different other affluents which are present on the shark skin and the shark body. So in a way, it is like the spa for the sharks and it is food for the remora fish or the sucker fish. The other very prominent example that you will come across is the case of the whales and the barnacles. So when you consider the whales and barnacles. So barnacles are the crustaceans. These are the species of crustaceans. You observe these are your barnacles. So barnacles in their larval stage, they require a surface to fix themselves. But at the same time, they require the availability of food. So that is when they oftentimes they attach themselves to the skin of the whale species. As the whale moves, the barnacle basically gets the availability of food through the plankton-rich waters. Because the whales follow the planktons, so that is where the barnacles get their availability of food. The barnacles don't damage the whale. For the whale, it makes not much of a difference. But for the barnacles, it is a kind of a provider of life. Similarly, you will find the barnacles attaching themselves even to turtles, for example. Right? On the shell of the turtles, you will find a lot of these barnacles settling themselves in. So this is also an example of commensalism. Then you have mutualism. Mutualism means a symbiotic relationship where both the species benefit. So here you can have multiple examples. One example is that of corals and zooxanthellae. So here the corals, they provide that stony calcium carbonate exoskeleton and their body structure and the tentacles for the zooxanthellae, which are an algal species. So the zooxanthellae, they settle on that. The zooxanthellae get nutrients in the form of various different salts through these corals. In return, the zooxanthellae, by the process of photosynthesis, they are able to manufacture their own food, which is required by the coral species. So this is what is symbiotic relationship or mutualism. Then you also have the case of the flowering plants, flowers and bees. So here, when we talk about the flowering plants, they have, or the plants have basically evolved to develop flowers very recently. That is, only a few tens of millions of years ago, flowers were developed by the plants in order to help them pollinate. So the plants, they have various different hues of colors of the flowers in order to attract insects such as bees. Now, once the flower grows, these bees, they stick on or they hook on to the flowers for availability of nectar. In return, the bee also gets the pollen grains stuck to its body. Now, after this flower, the bee will go to another flower, and in that case, it will drop these pollen and it will help in propagation and it will help in basically reproduction. So here also, the bee gets its nectar, the availability of food, the flower is able to propagate and multiply. So this is also the case of mutualism. Then you have aphids and ants and so on, multiple different examples of mutualism. You have another type of population interaction, and that is what we refer to as amensalism. Amensalism is a kind of an interaction where one organism is inhibited or destroyed while the other remains unaffected. One of them is unaffected, the other one is destroyed. So, for example, if you take the look at this image, here you will find the growth of a tree. Now, as this tree grows very quickly, suppose it is blocking the sunlight for the smaller plants here, right? So, for this larger tree, there is no impact. But when we talk about these smaller species, their growth is stunted, isn't it? You have the stunted growth. So, this kind of a relationship is amensalism. Many of the invasive alien species, for example, when we talk about Lantana camara also induces this. Lantana camara is a kind of a bushy growth of vegetation which blocks the sunlight for the native vegetation. So, while Lantana grows, but the remaining plants in that area, they are unable to grow. Same is the case with another species, that is Senna spectabilis. It is also invasive alien species. Senna spectabilis, a native of South America, gives the beautiful yellow flowers which are used for decorative purposes. But this is also an invasive alien species because, and it also follows amensalism because it blocks the availability of sunlight in that entire area. Okay? So these are the various species interactions: predation, parasitism, competition, commensalism, mutualism and amensalism. Okay. Now, after this, we come to what do we mean by ecosystem engineers. So, as we have seen that many of the times the ecosystem is not conducive enough. So, you have certain species who are able to modify the ecosystem. That is where the term engineers is used. So, these are those species which modify the ecosystem around them. Species which modify the ecosystem. Right. These are ecosystem engineers. So, they are of two types. So, here they are of two types. One is autogenic and other is allogenic. So, when we talk about autogenic, these are those kind of species which modify their own body functionality, their own body mechanism in order to change the ecosystem. For example, if you consider the case of a tree. Now, when the tree is small, when let's suppose you have a plant or a sapling. Now, at this point of time, at max you will have certain insects here, certain species of worms in that region, that's it. But when this sapling will grow, when this plant will mature, it will develop into a large tree. And in the case of a large tree, you will have species of birds, species of insects, parasites, snakes even, frogs in the region. All of them will be established in the ecosystem. So, here what has happened? The plant has modified its own internal biology or its own internal metamorphism has been carried out in order to change the ecosystem. So, that is self-modification. That is basically the autogenic. Then you have certain species who modify their external ecosystem, they modify their external surroundings. Example you consider beavers. Now, when you consider the beavers, generally found in the region around the water body, freshwater ecosystems, etc. But when they have to reproduce, at that point of time, they require static water. So, the beavers, they are so very smart and they are the nature's best builders. So, beavers basically if they see that a river is moving in this manner, they will accumulate the sticks, the woods around and they will construct a kind of a dam. So that in this entire area you have static water. Now that static water is then used by the beavers to accumulate food and raise their young ones. So beavers by building dams. Okay, by building dams. Generally found to be present in the region of North America, Europe, etc. Now, overall till now, if you have to summarize, we have seen what is an ecosystem. What are the factors controlling an ecosystem? How does that vary? What are the responses by the organisms? And also, what are the species interactions within the ecosystem and how is it that the organisms are able to modify their surroundings and the entire ecosystem as well. Right? Now, we come to what is referred to as ecological pyramid. What is an ecological pyramid? So, basically in any particular ecosystem, you have the presence of the food chain or the food web. Now, within the food chain, what do you have? Let's suppose you consider a terrestrial ecosystem where you have, let's suppose, the presence of grasses. Okay. Let's suppose you have the presence of grasses. These grasses are consumed by the deers. This deer is consumed by the tiger. This is a food chain. Now, different stages in a food chain, they are also what are referred to as trophic levels. Trophic levels. Now, in order to indicate the survivability, the sustainability and viability of an ecosystem, you need these food chains, etc., to be intact. So, in order to represent the relationship between the different trophic levels in an ecosystem, the ecosystem is represented in the form of ecological pyramids. Again, I will repeat. In order to represent the relationship between the different trophic levels in the ecosystem, you have the representation in the form of ecological pyramids. Now, ecological pyramids, they are basically of three types. When you talk about these pyramids, they are of three types. What are those? So, basically, you have the pyramid of numbers, then you have the pyramid of biomass, and then you have the pyramid of energy. What do these represent? So, when we say pyramid of numbers, so that represents the absolute number in each of the trophic levels. For example, the pyramid of number for this will represent the total number of grasses, the total number of deer, the total number of tiger. So, here you can always imagine that the number of grasses will always be maximum, then will come the number of deer, then will come the number of tigers. So, that ecological pyramid for this terrestrial ecosystem, that is going to be vertical. The number of grasses to the maximum, followed by the number of deer, followed by the number of tiger. Then you have the pyramid of biomass. In biomass, the dead weight at each of the trophic level is considered. So, for example, the dead weight of all the grasses, dead weight of all the deer, and the dead weight of all the tigers. Now, here the tiger population is very less. So, there the total weight will be lesser. In the terrestrial ecosystem, the pyramid of biomass will represent at the base the total weight of all the grasses, followed by the weight of the deer, followed by the weight of the tiger. So, there pyramid of biomass in the case of a terrestrial ecosystem will also be upright. But there is a twist when it comes to aquatic ecosystems. In aquatic ecosystem, what is the food chain? For example, let's suppose you have the producer in the form of phytoplankton. Now, these phytoplanktons are consumed by zooplankton. Now, these zooplanktons, they are consumed by small fish. Let's suppose mackerels, for example, small fish. These are consumed by larger fish. For example, let's suppose you consider tuna. They are then consumed by the predator species. Let's suppose orcas or the killer whales. In certain cases, you also have within the ecosystem at the end the blue whales. Now, if you consider the pyramid of biomass in this, phytoplanktons are microscopic. Even if they are present in millions, they are microscopic. So, their dead weight is less as compared to, let's suppose, 5 killer whales or 5 blue whales that you have. So, in an aquatic ecosystem, this pyramid of biomass is inverted. Okay? Otherwise, in the terrestrial ecosystem, pyramid of biomass is erect and is straight. Then you have pyramid of energy. Pyramid of energy represents that from one trophic level to another, what is the total amount of energy which gets transferred. It is very, very important in order to ensure the survivability of an ecosystem. Now, here 10% rule is followed. That whatever amount of energy is consumed by, let's suppose, the plants, 10% of it will be transferred to the higher trophic level. Whatever amount of energy is consumed or is received by the herbivores by consuming the plants, only 10% of it will be transferred upwards. So, because it follows the 10% rule, that is why pyramid of energy will always be upright. Always be upright. Okay. So, here if you take a look at it, in the terrestrial ecosystem, pyramid of energy is upright, pyramid of biomass, pyramid of numbers is also upright. When we talk about the aquatic ecosystem, in aquatic ecosystem, pyramid of energy, pyramid of numbers is upright, but pyramid of biomass is inverted in the aquatic ecosystem. Why? Because the base trophic level is composed of planktons. and these planktons are microscopic and hence their weight is the minimest. Okay, and then you have the pyramid of energy. So in the pyramid of energy, you observe the 10% rule. So as per the 10% rule, what do you have? That from the base producer, wherever you consider, only 10% of the energy gets transferred. The remaining portion of the energy is lost due to body metabolism, utilized by the organisms themselves, and also lost due to heat. So that is why invariably, under any ecosystem, under any condition, pyramid of energy will always remain upright. Okay, will always remain upright. Okay, keep that in mind. Now, after this, we come to another concept, that is ecological succession. So what do we mean by this? So, when you have a barren area, now in that barren area, it will not be the case that immediately you will have a wide variety of species living in that barren area. Initially, you will have certain species of mosses and lichens coming there. Slowly and steadily, they will be replaced by seasonal plants. Slowly and steadily, they will break down the rocks, weather down the rocks, and you will have the flowering plants. That will be followed by growth of maybe herbs and scrubs. That will be followed by another kind of trees, for example. So, here you observe that slowly and steadily the region is brought under habitation, but then it is one species after another which comes into existence. That is ecological succession. So basically, it is the steady and the gradual change in a species of a given area with respect to the changing environment. So it is a predictable change and is an inevitable process of nature where all the biotic components have to keep up with the changes. So here when we talk about the ecological succession, they go through various different stages. Now they are of two types, autogenic and allogenic succession. Autogenic means on its own. For example, let's suppose a new island has been created due to volcanic eruption. Now when a new island comes into existence, will it have soil? No, you will have barren rocks, right? So on its own, right? So here you will have barren rocks. Now in those barren rocks, can you expect the growth of a mango tree? Absolutely not. So in those barren rocks, initially you will have mosses and lichens. Now these mosses and lichens, they will come over, and these mosses and lichens, they will soften the ground. And that is when they will start inhabiting that. That is when they will break down the rocks and allow the formation of the soil, which thereby will be followed by the plant growth as well. Right? So this is on its own, a particular land has been created, pioneer species have come, led to the establishment of a climax community. Then you also have what is referred to as allogenic. Allogenic, let's suppose in a particular forested area, you have a forest fire. All the producer communities will be burnt. Now in that, you will again have the resurgence, right? The growth which comes back. So that is allogenic by outside interference. Okay, so this represents outside interference. Okay, now here if you take a look at the process of ecological succession, you will be able to see it has got various different stages. You have nudation, when you don't have anything on the surface, it is absolutely barren. That is nudation. After that, you have invasion, where you will find the presence of pioneer species. Pioneer species, the species which come there first. Pioneer species. So the pioneer species come to live in that area. So here example, mosses and lichens. Okay. That is followed by competition and coaction. where initially some of the plants, they make the conditions conducive for the survivability and existence of the other species as well. So that is competition and coaction. Then you will have certain species being pushed out of existence, survival of the fittest will happen, and eventually you will have the climax community, that is well established trees, which will come into existence. Now, different stages of this succession, they are known as the seral stages. Seral stages, or simply put, SEER. Now, this ecological succession is also classified into two types based upon the fact that whether a new area is colonized by the species or whether an existing area which has been destroyed by, let's suppose, a forest fire, industrial contamination, etc., whether that has been colonized. So, accordingly, you have what is referred to as the primary succession or pre-SEER, and you also have the secondary succession which is known as sub-SEER. Okay. So, you have two types of succession. When we talk about the primary succession or pre-SEER, it is just like what we discussed till now, that barren rocks to be followed by the pioneer species of lichens, to be followed by small annual plants, and eventually establishment of climax community. Now, this is a slow process, by the way. It can take hundreds, thousands, and sometimes even millions of years. This is where the species on their own, they colonize a particular region. But what is faster is the case of sub-SEER or secondary succession. Let's suppose there has been a case of a forest. Now, that forest is burnt down due to a forest fire. Then, after that, all the species, they again repopulate the area. That is what we refer to as sub-SEER. For example, when you consider the Chernobyl nuclear disaster in the region of the present-day Ukraine, where a nuclear leak happened in the 1980s. Now, immediately that region was depopulated, the species were dead. And the scientists and the biologists had predicted that the region will never come back to life. But very soon, you had the various different species coming back. So, sub-SEER happens very quickly, maybe within a decade or two, very quickly. Primary succession or pre-SEER, it takes a very long period of time. Now, after this, the term biome. What is the meaning of the term biome? So, when you hear the term biome, it was first used in 1916 by Frederick Clement to indicate a space, a living area for the species of plants and animals. That was the first usage of the term biome. Overall, if you take a look at the term biome, it is much larger than an ecosystem. Multiple ecosystems can be included within the biome, and it represents a particular climatic zonation within an area where you can have different types of plants, animals, etc. living there. For example, when you consider the tundra region, the Arctic region, you cannot expect elephants to be roaming there. You cannot expect mango trees or banyan trees to be growing there, can you? So, in certain climatic conditions, you will only have certain types of plants and animals living there. That is a biome. Now, in the 1930s, eventually, you had a German meteorologist who basically, and ecologist as well, named Heinrich Walter. Heinrich Walter divided these biomes based upon the climatic zones. So, the term was initially given by Frederick Clement, American ecologist. Frederick Clement gave this term in 1916. Okay? Then it was further classified by Heinrich Walter. Now, you have different types of biomes. For example, you have the dense forest, rainforest biome, then you have the savanna biome, desert biome, etc. Now, in all of these biomes, the species go through multiple adaptations in order to survive there. So, that is where you have to know the various adaptations. But a basic key difference between an ecosystem and a biome, So biome is a large naturally occurring community of flora and fauna occupying a large habitat. Ecosystem is included within the biome structure. So biome consists of many ecosystems that share similar climatic conditions. So they represent a large geographical area, whereas ecosystems, they represent a small geographical area, highlighting the biotic and the abiotic factors. So here, one biome can differ from each other based upon the different climatic conditions. One ecosystem can differ from each other based upon, let's suppose one has grassland, one has water, one has forest. That can be the differentiation of the ecosystem. Then tropical rainforest, grasslands, deserts, they can be the examples of biomes. When you consider wetlands, mangroves, etc., they can be the example of coral reefs, etc., can be the example of ecosystems. Okay. So when you take a look at few of the biomes, for example, the region of the savanna. Savanna is what is a very important biome. This is what is also known as a tropical grassland. Okay. So the savanna is known as a tropical grassland. Here you have a larger dry season and very small rainy season. That is why you will not find many of the trees growing there. You will have the presence of small grasses and shrubs. So when the rainfall occurs and when the rainfall is about to occur after the dry season, you will find thunder and lightning as the key causes which can initiate wildfires. So wildfires are very common in this area, which again does not allow the growth of many different trees. It allows the presence of these grasses. Then when you consider various different species such as elephants which roam in the savanna, so those elephants again, they limit the availability of trees by breaking them down, by stomping on them in their younger days. So that is where this is a grassland ecosystem to be found in the region of South America in the form of campos and llanos. So campos is the example of savanna in the region of Brazil. Llanos is the example of savanna in the region of Venezuela, right? Then you consider in Africa, the region of Masai Mara in Kenya, the region of Serengeti in the area of Tanzania. In India also in portions of Telangana, in the portion of Vidarbha region of Maharashtra, in the portions of Karnataka also, you find the savanna vegetation. Long dry season, very short rainy season. Okay, the rains occur generally during the summers. Now, then when you consider the desert biome, in the deserts, you have the species again undergoing modification. For example, the plants will not have leaves. Rather, the green pigments will be present in the stem itself. To allow them to manufacture the food on their own, you will have the stem having the green pigments. So due to this, the plants are able to manufacture food and simultaneously they are able to preserve water. Because if these plants would have had leaves, so through the leaves by the process of transpiration, the plants would have lost water. But because you have the stems having them, loss of water is not there. So these stems, they also store a lot of food. So that is why these stems develop thorns in order to protect themselves from any particular enemy and any particular kind of predation. So that is a desert biome. Here you will find the species also, the various faunal species or species of animals, they also undergo modification. For example, majority of the species you will find, they are nocturnal. They are active during the night. Why? Because the daytime is very, very harsh. Then you will find many of the species, they have the development of fur in order to ward off the extreme cold conditions which develop during the night. Then you will find also crepuscular species. Crepuscular means those which are active during the twilight and the dawn, right? Then you will find, for example, species of lizards. They will never secrete urine in liquid form because they have to extract as much water as possible. They secrete urine in the solid state. So these are some of the adaptations, the modifications that they undergo. UPSC has asked about these adaptations from savanna, from deserts multiple times beforehand. Then when you come to let's suppose the boreal forest biome. Boreal forest means the region of the taiga vegetation or the region of the conifers. Taiga vegetation or the coniferous region. So here, in this area, generally you will find that even though the rainfall is very less, the amount of evaporation also is so very less that there is moisture sufficiency which is maintained in this area. The region is abundant with moisture. That is why here the rate of decomposition is also slow. So the soil is very rich in organic content. Soil is rich in organic materials. Organic content. Now here you will find the species of trees having a conical shape and also having needle shaped leaves. Why? In order to withstand the heavy snowfall. That is why they need that needle shaped leaf. If they had the broad shaped leaf, all the snow accumulating on them would have broken the leaf structure. Needle shaped leaf allows them to shed that excess snow and maintain its structure, right? So here conical shape, as you can see in the image, conical shape and needle shaped leaves, right? This is the adaptation that is carried out. Then after that, when we come to the higher latitudes and even higher altitudes, you have the tundra biome. The tundra biome is where you have almost permanent ice, or during the summer season, you will have the presence of mosses and lichens. In the region around Antarctica, this has been in discussion because in the region around Antarctica, for the first time, some of the islands have indicated ice-free conditions throughout the year. That is where the tundra biome in that region is getting replaced. Now you will have mosses and lichens growing there, but soon to be followed by the flowering plants. That is again ecological succession. Okay. Now, there is another concept relevant for your prelims, and that is the concept of eutrophication. So, eutrophication is something which happens in the water bodies. Now, what do we mean by eutrophication? Eutrophication, simply put, refers to overloading of a water body, overloading by nutrients, right? So, which nutrients? So, here nutrients refer to the presence of nitrates and phosphates. Presence of nitrates and phosphates. Now, what happens is that when you have these nutrients overloaded, that is utilized. So, where do you get these nutrients from? So, industrial waste, untreated sewage, right? Excreta by the organisms, by humans, all of that enriches these water bodies with phosphates, nitrates, etc. Now, when you have the overloading by the nutrients, there is a significant growth in the algal population. So, the algal population indicates an increase. Algae and their population indicates an increase. Now, when the algae indicates an increase, blue-green algae for example, you will observe that they have covered the water surface. So, they will inhibit the availability of sunlight in the lower regions of the water body. So, as a consequence of that, you will have aquatic plants which will begin to die, right? When the plants begin to die, that means what? The enrichment of oxygen that they would be carrying out underwater, that comes to a stop. So, oxygen deficiency in water, right? Because the aquatic plants have died. Now, these algal species, they will also die. When they die, they settle down at the bottom to be replaced by new algae at top. They die and settle down. After that, they undergo decomposition. They are degraded by the microbes aerobic, various different types of aerobic bacterium, they work on that. So there is a decomposition which happens. When this decomposition happens, that is when you will have production of gases such as methane, hydrogen sulfide, which emanates that foul stench, but more dangerously, they will consume all the oxygen dissolved in water. So decomposition consumes more oxygen. Right? And that will give out that foul smell that you have associated with the water bodies. Now, as a consequence of both these events, you will find that the water body becomes hypoxic or devoid of oxygen in totality. And that is what leads to the creation of dead zones. Okay? So, eutrophication can lead to the formation of these dead zones. Eutrophication is to be found in small lakes, sometimes wherever you have stagnant water, even in marine areas, you can have the creation of these dead zones. So all of this happened because of the sudden explosion in the population of the algae. That is why this event is what is also referred to as a harmful algal bloom, or HAB. That is your harmful algal bloom, or HAB. Okay. So this is something which occurs in different areas depending upon the type of algae that you have. For example, off the coast of Florida, you have the growth of the red algae, and this red algae creates that reddish tinge in the water, and that is when the water appears to be blood red, and the tides associated are known as red tides. So when you hear the term red tides, it is associated with harmful algal bloom of a particular kind of red algae, red-brown algae, which grows in abundance, to be observed in Florida. In North America. Okay, in the region of North America. Okay, due to harmful algal bloom. So if you get a question statement trying to confuse you that this happens because of the lunar position, the solar position, etc., please don't get dissuaded by it. Red tides associated with the growth of red algae. Then we come to wetlands. Now when you talk about wetlands, they are also a kind of an ecotone between the aquatic system and the terrestrial ecosystem. Now what are these wetlands exactly? Wetlands basically are those marine areas, or not marine but aquatic regions, terrestrial aquatic regions of lakes, bogs, swamps, marshes, etc. There you can have the growth of the plants as well, and that is where you have a lot of species of birds, etc., which come to that area. Now these wetlands have various different benefits. For example, they act as natural sponges. So when you have excess water or excess rainfall, they are absorbed by these wetlands. Then they act as filtration system, where the larger pollutants or contaminants, they are held by these growth of the plant and vegetation, and cleaner water is allowed to pass through. Then they allow in the recharge of the groundwater, maintaining the availability of drinking water, recharge of groundwater, and they are also very vital for biodiversity. It is the destruction of wetlands in various areas which has led to creation of urban floods and disasters associated. So here, in order to restore the wetlands of the country and of the world, you have various conventions which have come into place. We will take a look into that. We have covered the Ramsar sites, new Ramsar sites under the portion of Conquer Prelims. You can take a look at the new Ramsar sites as well. But wetlands mean those areas which are inundated or saturated by surface or groundwater at a frequency and duration sufficient to support the vegetation and the species associated. Can the wetlands be man-made? Absolutely yes. You have man-made wetlands, for example, reservoirs. Reservoirs can also serve as wetlands. You have artificial wetlands which have been created in order to get rid of the contamination in an area by the biological processes. So wetlands can be artificial as well. Now, in order to protect the wetlands of the world, you had the Ramsar Convention. Ramsar Convention was signed when? Ramsar Convention was signed in 1971, 2nd of February 1971 in the Iranian city of Ramsar. And the effort was to conserve the wetlands. It came into force in 1975 is when it came into force. The first Ramsar site was designated in Australia. Okay, that is the Ramsar Convention. Now, in order to protect and promote the wetlands, you have the Ramsar sites which are allocated, which are designated as Ramsar sites. India in total as of now has got 82 Ramsar sites. Now, certain Ramsar sites require urgent amount of attention, require urgent amount of care and protection. Those kind of Ramsar sites requiring that urgent protection, they are listed in a record which is known as Montreaux record. Okay, that is requiring urgent attention and preservation. Okay, preservation. That is Montreaux record. India has also launched another program for the conservation of the wetlands, what is known as the Amrit Dharohar scheme. So, Amrit Dharohar scheme is for what? It is for maintenance and resurgence, sustainable tourism facility, sustainable usage, wise use principle that is associated with the Ramsar, and that is something which is highlighted by the Amrit Dharohar scheme as well. Okay. Now, then another important ecosystem is that of a mangrove. Mangroves, they provide security to the coastal areas against natural and the disasters such as tsunamis, such as when you consider storm surges, cyclones, etc. But at the same time, mangroves are very important ecosystem in terms of maintenance of biodiversity. Now, these mangrove vegetation, they undergo certain specific kind of modifications and they undergo certain adaptations in order to adapt to the conditions of the marine ecosystem where they grow in a submerged area. Now, many of the times you will find that the roots are submerged, right? And they survive in that. So, when we talk about the mangrove vegetation, what is important for your exam is to understand the adaptations that they go through. One of the adaptation is development of pneumatophores. What are pneumatophores? So, because they grow in areas which are muddy, marshy, inundated with water, that is why you will find that some of the mangroves, they develop the root system where the roots basically start protruding out of the ground surface. In order to get the availability of air and oxygen, the root nodules, they start coming up from the ground surface. Those are pneumatophores. Then you have vivipary. Vivipary or viviparity is when in an existing tree, let's suppose here, you will have a plant or the young one growing here itself. From the seeds, it will germinate. Why does it happen? Because mangroves, let's suppose, if you consider a new young plant, basically, or the seed falling onto the ground and then germinating, what will happen? You have water which is moving around, so the seed will be carried around. That is why the mangroves undergo viviparity, where the young ones or the seed germination happens while they are still attached to the main plant. Once they grow large enough, then they basically fall and plant themselves on the ground. Then, in order to withstand the saline water conditions of the marine areas, these mangroves, they also have the salt secreting glands that is present in the leaves of the mangroves. Because generally, the xylem and the phloem of any plant will allow the movement of water, and that water is passed on to the leaves and lost by transpiration. if a normal leaf structure would have been present, if let's suppose a normal leaf structure would have been present, then all the pores would be blocked by the salt. Right? That is why the leaves in the undergrowth, they have these salt secreting glands which secretes the salt present in the water, and the normal functionality is carried out. Then you also have the presence of adventitious roots. Adventitious roots where you have multiple root systems like this. Now this plays multiple beneficial roles. One of the beneficial role is that it provides the strength to the tree in place. The other beneficial role is availability of oxygen. Strength is required in the case of the tidal movement, etc. The mangroves require strength, so that is where you need adventitious roots. Okay. Now these mangroves are very advantageous. They provide fisheries activity, they provide the facility to mitigate climate change by absorbing huge amount of CO2 as well, right? So they have a various and different kinds of benefits. In the region where you have mangroves, they allow the filtration of water also by trapping the contaminants. Many of the times you will find that increased amount of organic production within the root systems means there are a lot of fishes which grow in the region of the mangroves and the base of the mangroves, right? So they are very beneficial. But the threats that they face are largely in the form of extension of agriculture, tourism, unsustainable tourism, cutting of the trees for accumulation of wood. And these events, they create a loss of biodiversity. That is why, in order to protect the mangroves, the government of India has launched the Mishti scheme. Mishti scheme is a government of India scheme in order to populate or carry out the forestation of around 504 square kilometer of mangrove vegetation in around 9 states and union territories. This Mishti scheme is being implemented on a public-private partnership, which allows the transmission of the best practices, the best ideas, and increasing the mangrove vegetation. Across the globe, you have an initiative carried out by UAE and Indonesia, and that is Mangrove Alliance for Climate. Okay, that is Mangrove Alliance for Climate. Here, Indonesia is substantially rich in terms of the mangrove vegetation, even when it comes to the species diversity. That is where these are the countries which have launched this program. Okay. Now, another thing which is relevant for your examination this year, and that is the climate tipping points. What do we mean by climate tipping points? Now, climate change is again an important topic. Now, climate change is causing warming in various different parts of the world. But there are certain events which, if triggered, then the climate change will happen on its own. Those are known as tipping points. For example, when you consider the melting of Arctic ice, right? Now, when you consider the Arctic region, it has got thick ice. Now, the thicker the ice, more is the solar rays that it will reflect, isn't it? Now, let's suppose due to climate change, due to some event, this ice thins out and in certain region even water is exposed. Then what happens? These solar rays, some amount of it will be reflected, much amount of it will now be absorbed, right? Because thicker ice is more whiter, it will reflect more. Now, as a consequence of this, what will happen? More heat is absorbed. More heat is absorbed means what? More melting. More melting means what? More heat will be absorbed again, right? So, it is a feedback cycle which will be initiated. Like that, you have various events across the planet which, once triggered, can lead to an exponential warming on its own. A positive feedback loop in the global warming will be initiated. So those are known as climate tipping points. So you have various different climate tipping points which can be triggered if the heating is around 2 degrees Celsius, if the heating is around 2 to 4 degrees Celsius, and so on. This is important for this year's examination. So here, for example, when we consider the dieback of Amazon rainforest, what do we mean by dieback? So let's suppose the Amazon rainforest, they are replaced by grassland ecosystem. Right? Why? Because of lack of rainfall if they are replaced by grasses. So what will happen? These grasses will not provide that much moisture in the atmosphere as compared to a rainforest. So when moisture is not provided means less rainfall. Means what? The existing forest will also decline in population. That means the entire rainforest eventually will be replaced by grasses. That will cause greater amount of warming. Isn't it? Forests provide shade and provide some cooling. So this will automatically trigger a cascading set of events. Similar is the case with the Greenland ice sheet collapse, the West Antarctic ice sheet collapse, the Bering Sea winter ice abrupt loss, Arctic winter ice collapse, boreal permafrost when it thaws, right? Permafrost regions, when they start to melt, then what will happen? Again the same thing. It was covered by ice, will reflect much more. If it is replaced by barren rocks, it will absorb more heat, more heating. And in the case of the permafrost, many of these permafrost regions, they have basically many of the species over a period of time who have died and have been preserved in this permafrost. Now let's suppose this permafrost melts. What will happen? All the methane and the carbon compounds trapped within the ice will be released. Suddenly the greenhouse concentration in the atmosphere is going to increase. With the increased greenhouse concentration means what? Greater amount of warming will happen. And as a consequence, this will kick on further heating, further melting of permafrost, more release of methane and carbon, and like that the heating will continue. So you have these particular areas which are a case of climate tipping points. For example, the Labrador Sea subpolar gyre, Atlantic meridional overturning circulation, which is a thermohaline circulation. If that does not happen, which is already being the case, where the overturning of water is not happening from one region to another, so the water is remaining in the same area for a longer duration. As a result, greater amount of storms due to increased heating in the northern Atlantic is happening. Okay, so one has to know what are the tipping points. That is something that you can know. So greening of the Sahel region, which is an ecotone, if it becomes green, that can also induce further warming by increased vapor presence in that area. So that is the example of tipping points. Now, after that, we come to biodiversity and different components of biodiversity relevant for your prelims. So when you talk about biodiversity, you have different elements of biodiversity. For example, in any particular region, you have the ecological diversity. What is meant by ecological diversity? So let's suppose you consider any particular region within India. Let's suppose you consider the region of Madhya Pradesh. Now, in the region of Madhya Pradesh, you will have aquatic ecosystem also, grassland ecosystem also, forested ecosystem also, rocky ecosystem as well. So you have different types of ecosystems. When you have the presence of varying kind of ecosystems, that is very important for the survivability of wide variety of species. Otherwise, you will only have a limited set of species living in that area, which will always be prone to extinction. So ecological diversity is important. Then same is the case with the genetic diversity. Genetic diversity basically means, for example, when we consider the tigers, you have Royal Bengal tiger, you have the Sumatran tiger, you have the Amur or the Siberian tiger. This genetic diversity means that one particular species is not vulnerable to any kind of external harm. And if an external harm comes, does not mean that the entire species will be wiped out. This is the reason when we talk about the lion population in India, lion population in India lacks the genetic diversity. All of them are Asiatic lions and situated in the same region. So if, let's suppose, there is a disease which sweeps through, the entire population can be at risk. That is why there has been plan to relocate the lions from the Gir region now to the Barda Wildlife Sanctuary under Project Lion at 2047, a vision for Amrutkal. The relocation of lions has been sought from the region of Gir, some of the lions to be located in Barda and eventually in other areas of Madhya Pradesh and so on. That is to maintain the fact that even if you don't have genetic diversity, you need to have the survivability of species. Then ecological diversity also automatically ensures species diversity, very important for maintaining the food chain and a varied food web network as well, so that you have alternate food sources and competition does not kill any particular species. And you also need the functional diversity. Functional diversity is what? That you have various different biogeochemical cycles, nitrogen cycle, carbon cycle, sulfur cycle, oxygen cycle, water cycle, all of them should be functioning. The role of the food chain, the decomposers, the producers, the consumers, as long as these functions are varied enough and resilient enough, the ecosystem is sustainable. Okay, so that is the case of functional diversity. So these are the diversities required for maintaining biodiversity. Even within a particular area, you have different scales of diversity, which are measured by what we refer to as alpha, beta and gamma diversity. What are they? For example, when you consider an ecosystem like, let's suppose, a lake. Now, in that lake, what is the biodiversity? What different kinds of species are present? That is alpha diversity. Okay, so the mean diversity of species in different sites or habitats on a local scale. Then you compare it with, let's suppose, the grasses. How many different types of species are there? Now, beta diversity is what? When you maintain or compare the species diversity between two communities or two different ecosystems. For example, if you have the grassland and if you have the desert, in between these two ecosystems, if you compare the diversity, that will be beta diversity. So beta diversity of grassland will be much greater because there you have a producer community in the form of plants in abundance. So that is the comparison of the diversity in between the ecosystems. You also have what is the gamma diversity. For example, let's compare the region of Himalayas with, let's suppose, Andes. Now, Himalayas will have multiple ecosystems from the foothills to the top. Same is the case with the Andes as well. So, when you compare these two in terms of the species diversity, that is gamma diversity. A quick recap. Alpha diversity is when you compare the diversity within the ecosystem. Beta diversity is when you compare the diversity between two ecosystems. Gamma diversity is when you compare the diversity in between two different landscapes altogether, many of the times in between two different biomes for that matter. That is gamma diversity. Now, when we talk about the biodiversity, the species are classified based upon their functional role. So you have the indicator species. They indicate to you, they give you an idea about the health of the ecosystem, whether the ecosystem is healthy, survivable or not. So for example, in the marine area, let's suppose you have the corals. Corals and zooxanthellae population won't survive in polluted water. So, the presence of corals and a thriving zooxanthellae population gives you an idea that the marine waters are clean and healthy. Same is the case with the case of air quality. Lichens, for example. Lichens give you an idea about the health of the air around. If you have increased sulfur load in the air, lichens will not be present. So, these are indicator species. Peregrine falcons, for example, give you an idea about the pesticide load in a particular ecosystem. They indicate something. Then you have keystone species. Keystone species are vital for the survivability of the entire ecosystem. So, indicator species give an idea an idea about the health of the ecosystem. Example, peregrine falcons. Example, lichens. Example, zooxanthellae and corals. Right? These are the examples. Keystone species, they are important for the survivability of the ecosystem. For example, we have discussed about tiger. Let's suppose the tigers go extinct. Deer population will explode. Those deers will consume grasses. Overgrazing will happen. Destruction of the ecosystem health will happen. Isn't it? Tigers keep the population of deer in check. That is a keystone species. Then, when we talk about certain species and their conservation, many of the times the species give a larger message. They are a symbol of protection or a particular message. For example, when you consider the case of pandas, the panda population is associated with animal conservation. That is why they are oftentimes regarded as a mascot for World Wildlife Fund for Nature. When you consider, let's suppose, the elephants, the male tuskers, for example, again are a mascot to prevent poaching of the animals for the illegal trade. So those kind of animals, those kind of species which gain a larger importance, a larger value of conservation, those are known as flagship species. Example, elephants, panda, etc. Then you have foundation species. What do we mean by foundation species? These are those kind of species which lay the foundation for the creation of an ecosystem. For example, in the marine area, you have the corals. So that region might not be very populated. But when you will observe the growth of corals, then automatically due to the availability of food, lot of organisms will flock to that area. Lot of organisms will come to that area. That is what is referred to as foundation species. They create the ecosystem. Create the ecosystem. Example, you have the corals. Corals in marine environment. Okay? That is basically the classification of the species. Okay? Now, then a couple of pointers relevant for your exam, that is biodiversity hotspots. So biodiversity hotspots, these are those areas of critical biodiversity concentration where overall they are around 36 in number. Overall, they represent only around 2.5% of the Earth's land surface, but represent more than half of the world's plant species as endemics and 43% of the animal species as well. So here, in order to get classified as a biodiversity hotspot, these are the various biodiversity hotspots across the world. In order to get classified as a biodiversity hotspot, you need certain conditionalities to be fulfilled. For example, that region should have at least 1500 vascular plants as endemics. Endemic means to be found in that region and nowhere else. And not any kind of plant, vascular plant having the proper growth of xylem and the phloem. Then at least 70% of that vegetation would have been lost. So the region is endangered. Endangered meaning 70% of the vegetation is lost. That is the criteria under which the region is classified as the biodiversity hotspot. So here one thing that you have to keep in mind for your exam is that these biodiversity hotspots can be present even in the temperate areas. Many of the times the question can be framed that because of increased productivity, biodiversity hotspots are restricted only in the tropics. No, they can be present in the temperate regions of the world as well. In India, you have 4 biodiversity hotspots which lie partially or completely in India. Which are those? You have the Himalayan biodiversity hotspot, the Himalayan biodiversity hotspot in the northern region, the alpine region, the Himalayan area. Then you have the Indo-Burma forested area, that is another biodiversity hotspot. Various different species of birds, for example, monkeys, for example, they are to be found in this area. Many types of hornbills, for example, are to be found. Then you have the Western Ghats and Sri Lanka, where you have unique species such as lion-tailed macaque. When you have hornbills, they are to be found. And then you have the Sunda Land biodiversity hotspot. Sunda Land biodiversity hotspot lies in the island region of Great Nicobar. Okay, so these are your 4 different biodiversity hotspots which can spread across multiple countries. Please keep that in mind. Biodiversity hotspots are not bounded by the territorial line of a country. Now, this means that oftentimes conservation is not that long lasting. Because, for example, when you consider a species present in Indo-Burma biodiversity hotspot, let's suppose elephant. Now, an elephant is hunted or the elephant population comes down in this area. Myanmar can turn around and say that hunting and poaching is happening in India. India can turn around and say that we are protecting, it is happening in Myanmar. Who is accountable for the conservation? So, in order to bring accountability to the process of conservation, certain countries, they are named as mega diverse countries. So, that is basically to bring more accountability into conservation. So, when we say mega diverse countries, these are the countries which have large amount of biodiversity, right? So, this raises national awareness for the process of conservation, and the entire biodiversity is then protected. So, for the mega diverse country or for a country to be declared as mega diverse, certain criteria must be fulfilled. For example, at least 5,000 of the world's plants need to be endemic to that region, to be found nowhere else. In the case of biodiversity hotspot, the region needed to have 1,500 vascular plants. Here you need to have 5,000 different species of plants, not to be found anywhere else. Then, have marine ecosystems within its borders. These are the 2 main criteria. Other than that, the species uniqueness, whether a species is a keystone species or not, the endemism, these can also be used. But primarily, these are the 2 important criteria. Is India a mega diverse country? The answer is yes. Are mega diverse countries located only in the tropics? The answer is no. So, here you will observe that none of the countries in Europe, they are a part of mega diverse countries. None of them. Okay, because of lack of species richness. Maximum number of mega diverse countries are situated in Asia and in the region of South America. Okay, so that is something you have to keep in mind. Now, these particular species, generally when we talk about the biodiversity, it is more populated within the tropics. Because historically in the tropics, the climate has remained predictable, has not changed even during the ice ages, and due to greater solar insolation, more plant growth, more productivity is carried out. Now, when we talk about the various different species through the history of time, many of the species have gone through what is known as mass extinction. So, when we talk about mass extinction, what is that? So, mass extinction basically refers to that event in history where suddenly majority of the species have ceased to exist. All of them have died due to at least 90% of the species, 70 to 90% of the known species at that point of time, they have ceased to exist due to extremely harsh conditions. So, till now the planet has witnessed 5 mass extinctions, and they have happened due to various reasons. Global volcanic eruption, asteroid impact 65 million years ago, a global freeze around 500 million years ago. Eutrophication of oceanic waters, leading to the death of all the marine species of that time, due to which many species were forced to come to land. Continental drift inducing sudden climate change. So various different mass extinctions have happened. The fifth mass extinction happened 65 million years ago, when you had an asteroid which struck the surface of Earth, and that eventually led to the death of the dinosaurs as well. But presently, due to human influence, you have the sixth mass extinction which is underway. Sixth mass extinction is anthropogenically caused extinction. That is, induced due to human actions, the extinction is happening. Right? It is presently undergoing. We are a part of this. Now, what also becomes relevant for your examination here, that there is one particular species which has survived all the various different phases of mass extinction. And that species is tardigrade or water bear. Now, this tardigrade or water bear has the ability to shut down its metabolic activity. It is microscopic. It has the ability to shut down its metabolic activities as long as the harsh conditions prevail. They can survive in the deepest of the space. We have tried to kill it. In the deepest space, it has survived. They can survive in saline conditions, acidic waters, everywhere. This is one of those which has survived the mass extinction. Okay? So, that eventually brings us to the conclusion of the session here today. So, overall, in today's session, which was slightly longer because of the requirement of the examination, just have a recap of what we have covered. We started with the basics of ecosystem, covered what is an ecological niche, what is an ecological pyramid, what is the pyramid of biomass, pyramid of energy, what are ecosystem engineers, what do we mean by ecological succession, what do we understand by the biome, difference between a habitat and a niche, difference between a biome and an ecosystem, examples of biomes and the adaptations that the species undertake in order to survive in those biomes. What is a wetland? The scheme for the conservation of wetland. What is a mangrove? The global action for the conservation of mangroves. What do we understand when we talk about the types of biodiversity? The different climate tipping points, the utility of those. Mega diverse country, biodiversity, hotspots. So in total, starting from ecosystem, coming up till mass extinction, this particular portion is going to be very vital for your prelims examination. If you have liked this initiative of ours, do show your appreciation by clicking on the like, share and the subscribe button, and in the comment section, do tell us and do let us know about what you have felt for this particular session in terms of content enrichment. I hope that this has added value to your existing knowledge set and will help you when the time comes for the prelims exam. So see you after the prelims for the paper discussion. Maintain your calm, maintain your confidence, revise, revise and revise. And all the best for the upcoming exams. Thank you. Goodbye.